Allumage 2 ESR, décollage.
And liftoff of New Glenn Marine.
Good morning, afternoon, or evening, wherever you're watching from, and welcome to the live coverage of the 2026 total solar eclipse here. Now, of course, we are in, well, I'm not in Spain, but the camera view here is in Spain. Now, personally, I'm from the Netherlands, so the 90% solar eclipse here will be earlier than the totality here, but I'm hoping that we can get my camera feed on just to show you how dim it gets. So yeah, so you can see the sun just going past the camera here. Of course, we are also hosting a TSDG clean feed stream. If you want to check that out, you can head over to the clean feed stream and only have the TSDG logo and the broadcast we are showing you. Now, reminder, we are also live on the Bravo Yankee Tango channel, which is our partner we work with. And this broadcast for the people at Bravo Yankee Tango will be hosted in English, as this TGG has always been hosted in English. So, with that, just chilling here, because I don't think there's anything to do, really, in the next 1 hour, 30 minutes, at least here. So, if you guys want to talk, have any questions or anything, make sure to ask them in the chat. But until then, we're just gonna chill here. I believe we also have a multi-view of... there are no names for the multi-view, so I just called them whatever. Broadcast feed 1 and broadcast feed 2. I just called them whatever. So I could also, what I can do, I can give them a no. Well, I cannot give them a no name now. It's too late now. But yeah, this is how things are looking. Now I basically let this run all day, and for the people on Twitch or seeing the multi-view, kind of spoil it too much, because then everyone looks at the multi-view stream. Don't want that. We've been running for 3 hours, but because they've been live for a long time as well. The views we're getting have been live for a very long time here, and will be for the duration of this eclipse. So on the main stream, you can see 2 shots of the sun from 2 different locations, and now just 1, but both still from different locations. And you can see the beach. A reminder, the solar eclipse today will be, I believe, yeah, it's still before sunset, but I believe half an hour after the eclipse there will be sunset. So I don't think I will be able to see personally from where I'm at, because yeah, the sun is way below the houses and stuff. But we will probably notice it getting dimmer outside. A little more gray, I should say, grayish. Now, I've personally never seen the sky get grayish before, so it's going to be pretty cool seeing it get a little more darker, even in this almost sunset conditions. I don't want to say darker too much, because it's not really. I don't know how to explain it. And it reminded, that's just from what I've heard, because I've never personally experienced it before. But that will change today. I'm unsure myself when the NASA broadcast will start. I believe it was going to start. I don't know, actually. Hold on. NASA. Oh, they begin 10 minutes. So, dang it. Okay. What I think I'm gonna do. You're gonna have to hold on for a minute before I tell you guys what's up. I think what we're gonna do is we're gonna have the NASA coverage on for a lot of the stream. If they are gonna have commentary, we'll have their commentary up. But of course, staying with these views we have now, and I'll interrupt, of course, a few times. Now, I'm just checking a few things. Now, for this stream, we will have. Why is it not working? Okay. For this stream, we will have the NASA commentary on. If you're looking on the clean feed stream, we will just have the views of the outside world here, where you're looking at right now. And also this. Beautiful sounds, I should say. Well, it's not really beautiful. It's just the sound of Earth, nature, I guess, and the streets and the beach and stuff like that. Because there's a drone shot on right now. I just want to take a look. Drone shot off the beach. It's kind of interesting. Drone shot off the beach, but yeah. That's something. Now, of course, the other shot we just had was from, I cannot pronounce it, so I'm just going to say Teruel, Spain. But you can see it on the bottom right of your screen, the location of where this is. Now, this is not, well, I mean, this is more at the beach at Spain, so it's probably, I would say, the left side of Spain or somewhere in between. I mean, they wouldn't be standing here if it wasn't the total, I think. So, this is probably left side coast. And there you see people at the beach there. So, going back to the NASA coverage, I believe there's music playing. There is. I just want to check. Okay, it does not get picked up by the clean feed stream, I believe. So, once again, if you're just joining us here, you're looking at the 2026 total solar eclipse here, and there's beautiful views of the sun. And another view, actually, I just want to get to that. Just give me a second. And there's that. Two suns. One is bright, one is perfectly stable in terms of views. You can see there. I just want to say, for people just hopping on the commentary stream, like I said, on the clean feed stream, it says here, time of totality depends indeed on the location. So, Red Corey Okay, Red Quarry asked how been where you locate, but this video is the location Spain. I think Red Quarry and anyone else would locate with this vid. How long until totality in Spain at this location? I should actually put a countdown for them. That is maybe smart. Yeah, I got the... Yeah, alright. Well, cannot wait to see the solar eclipse here. We're still quite far away from that, so... Now, since we do got a little bit to go, we are going to travel to the NASA broadcast in about 4 minutes time. So just a reminder that will happen. Alright, so we'll put the NASA coverage on now, and until then, enjoy the views you're seeing here. We'll be back probably soon. Just realized it's gonna take a little bit before NASA starts their coverage. Still like 3 minutes out. Pages, welcome to the stream. Nice to see you here today. We're still quite far away from the solar eclipse here, so if you want to just relax in the stream, otherwise you can come back later to see the solar eclipse. Do want to remind here, once the NASA coverage starts, we will be only answering questions via chat on both Clean Feed and the normal stream. If you, of course, have any questions then. At the moment, just kids looking around, seeing the sun. I believe we're still at the roof. Monte Javelin, Tyrrell, Spain is where feed 1 is coming from. What will be annoying is I'm going to have to constantly switch. Because one has better views at one point and the other has better views at some point. So it's kind of annoying switching, but I guess that's what we're going to do. Iceland has thick clouds. Okay. Yeah, that might be annoying. They're just seeing the people, probably getting a tour of whatever is going on, if not. Okay, so NASA is live now for their coverage, so we're just going to head over to their coverage for a little bit here, and we'll probably be back with our own commentary once I feel like it.
Instant chills. I burst into tears.
There's no other feeling like it. It's insane.
Everybody should be watching. Hello and welcome to NASA's live coverage of the 2026 total solar eclipse. We're at NASA's Goddard Space Flight Center, and over the next hour or so, we'll be tracking the eclipse as it races across the North Atlantic and Europe. A total solar eclipse occurs when the moon moves between the sun and Earth and completely blocks the face of the sun, casting a temporary shadow on Earth. People located within the moon shadow, also known as the path of totality, will experience a total solar eclipse. The sky will darken briefly as if it were dawn or dusk. So weather permitting, people in the path of totality will see the corona, the sun's outer atmosphere, which is normally hidden by the bright face of the sun. Today's total solar eclipse will sweep across Greenland, Iceland, northern Russia, Spain, and a small corner of Portugal. Many other areas in the northern hemisphere are already or will soon experience a partial solar eclipse, including much of Canada and parts of the northern US. And for many along the western part of the eclipse path, such as mainland Europe and Africa, the eclipse will occur early evening, creating a rare opportunity to see a sunset eclipse. Over the next couple of hours, we'll be bringing you live feeds from telescopes across Europe and hopefully views of totality in Iceland and Spain. Thank you so much to our partners, Time and Date, Southern Illinois University, and Exploratorium for those views. During today's show, we'll be joined by experts to learn why celestial events like these ones are important to study, document, and experience. And I have an important reminder on that note. When watching a partial solar eclipse, you must always use the right protection. You can use safe solar viewing glasses like these ones called Eclipse glasses, or a safe handheld solar viewer like this, or you can use indirect viewing methods as well. Regular sunglasses, no matter how dark, will not work and are not safe for viewing the sun. So be sure to stay safe. Now, let's head over to my colleague Ernie Wright, who can tell us more about where the action is happening today.
Thanks, Joy. I'm standing in front of the map that I made for the eclipse that we're going to experience today. We're looking down at the North Pole here, and the red stripe is the path of totality. Those are the locations that will experience totality today. As we animate this, you can also see the much broader penumbra shadow. That's where the partial eclipse occurs. But here comes the umbra shadow. That's where totality is happening, inside that little oval. It passes over the east coast of Greenland, the west coast of Iceland, and across northern Spain, where, as Joy said, they'll experience an eclipse within an hour of sunset, so they should have lots of opportunities for really beautiful photographs. And then as the eclipse progresses and that umbra disappears, West Africa will also get an opportunity to see a partial eclipse as that penumbra shadow sort of slides off the edge of the Earth here. Now, as we zoom up and look at Iceland and Spain, Reykjavik is here in that southwest corner of Iceland. We're kind of crossing our fingers for them because it's a little bit cloudy there right now. That umbra shadow is traveling over 2,000 miles an hour as it passes through the path and crosses the North Atlantic. And then it runs into Spain here, where we expect more than 15 million people will be watching this eclipse. Some of them on the beach in Mallorca right before sunset, so they should get some really beautiful photographs over the mountains to the west. Now, the situation in the US is going to look like this. That yellow line is the southern limit of the partial eclipse. So folks south of that line, you're not going to see an eclipse today. But if you're north and east of that line, you may already be starting to see the partial eclipse. It takes 2.5 hours for that partial shadow to pass all the way across the United States. So it's not like totality. You don't have to run out there at the exact moment. Some places will have a partial eclipse that lasts for almost 2.5 hours. Others, maybe just an hour. So this is the situation right now. Montana, your eclipse is over. The shadow is passing out of North Dakota, but Minnesota, Wisconsin, Michigan, you're in it. The Northeast is also in it. And for folks in the Mid-Atlantic, you will be in it soon enough. Now, before you run outside to look at your eclipse that's happening right now, we want to show you a short video about how to observe this eclipse safely.
If you'd like to find and explore the animated eclipse maps yourself, like the ones Ernie was referencing, safety instructions, and much more about today's eclipse, head to science.nasa.gov/eclipses. So next, I'd like to introduce our first guest here in the studio. We have Dr. Kelly Corrick, who is one of NASA's heliophysicists, who studies the sun and its effects across the solar system. And she's also studied the sun's corona in great depth. Thank you so much for helping us kick off today's coverage.
It's great to be here, Joy.
So let's talk about why we don't always see eclipses on Earth. We've got this awesome model here called an ORI. So using this, can we talk about their orbits and why we don't see it every month?
Yes, so here we have the sun, the moon, and the Earth. And as we move, we can see that the moon is not exactly on the same line that we have with the sun. So the Earth can view the sun pretty well, but when we get it to about here, we can see that sometimes, maybe a little further, sometimes it lines up perfectly so that we're able to have that eclipse. And that's when we have that eclipse. So that 5 degrees off ends up not having eclipse every new moon.
Okay. And so today's eclipse will travel across Europe for the first time since 1999. Yeah. Can you tell me, why does that region not experience eclipses as often? And what is it that makes this eclipse unique?
Right, so this eclipse is unique because of the fact that it's near sunset. It's also the fact that Europe doesn't get as many just simply as to the location, and any place on Earth, really, it's about 300 to 400 years between the time you get eclipses. So there's a lot of ocean on the Earth that it just doesn't go over land. Plus with the angle, it tends to move very quickly and pass in and out, so they don't get a lot of eclipses. And again, it's super special being near sunset, so being able to see a sun setting being eclipsed, it's going to be really awesome photos.
Okay. And I've also heard of eclipse seasons. Can you talk a bit about that?
Yeah, so an eclipse season, when an eclipse happens like this, that lineup means that you're going to see the solar eclipse, so either a partial, annular, or total, and then you're going to see a lunar eclipse about 2 weeks later. So in about 2 weeks, we'll be able to enjoy the orientation where the Earth is actually casting the shadow on the moon and having a lunar eclipse. So that's the eclipse season.
Oh, fantastic. And I know Europe is going to have another eclipse happening, which seems to be a lucky few years for that region.
Yeah, definitely lucky, and it's going to be a wonderful eclipse, and actually the longest eclipse of the century. So it's going to be 6 minutes and 28 seconds. So that's a very long one. Great for scientific investigation.
Wow. And so eclipses can occur somewhere on Earth roughly every 18 months or so. So why is it that NASA continues to study solar eclipses?
Because every eclipse is a little bit different. The sun changes as it rotates or changes its 11-year cycle. The Earth and the area of the Earth that it covers is different. So we make sure that we study it each time.
Fantastic. Thank you so much, Kelly.
Thank you.
So throughout today's coverage, we'll be joined by other NASA experts like Dr. Kelly Corrick, who can answer any of your questions that you have about solar eclipses, the science we're doing, and all the other activities you're hearing about today. You can ask your questions in the chat on YouTube, Facebook, Twitch, and Instagram, or tag at NASA wherever you're Instagram, or tag at the NASA experts like Dr. Kelly Corrick, who can answer any of your questions that you have about solar eclipses, the science we're doing, and all the other activities you're hearing about today. You can ask your questions in the chat on YouTube, Facebook, Twitch, and Instagram, or tag at NASA wherever you're watching. We also have questions we want to ask you today. So if you want to head over to NASA's Twitch or Instagram stories and take a look at the poll we've got for you, you can participate and answer those questions. And so before we go on, I just want to point out that you may have noticed a clock counting down in the upper left corner of today's show. We'll have 2 different countdown clocks displayed over the course of the next hour that will let you know how close we are to the first instances of totality in the telescope views we have in Iceland and Spain, respectively. Those are the 2 locations where we hope our telescope partners will be able to capture the best views of the sun being totally eclipsed by the moon. We're tracking totality in Reykjavik, Iceland at 1:48 p.m. Eastern Time, or 5:48 p.m. local time, and that will last about a minute or so. And then we're going to set our sights to Leon, Spain, for totality there at 2:28 p.m. Eastern Time, or 8:28 p.m. local time. And the eclipse there will be about 2 minutes long. So there's a lot of science taking place during those fleeting moments of totality today in Iceland, and we have experiments on the ground and in the air. And in the view looking at right now, there's a camera that will be capturing the view of the sun's corona when it's time for totality. When totality hits in Iceland, the planes are going to be chasing the moon's shadow for as long as they can. They're going to be studying the sun's corona, where the skies will hopefully be clear up there. The plane took off from Keflavik Airport about an hour ago, and then we're going to be talking to the science team live from Iceland very shortly. Before we do that, let's learn more about what it's like to be a NASA pilot in those eclipse experiments.
For most people, a total solar eclipse lasts just a few minutes. But NASA's pilots find a way to make it last longer by trying to outrun the moon's shadow with an airplane.
The truth is it's actually chasing us. We get out in front of it and let it overtake us. Once we're in totality, then we'll advance the throttles to max and try and stay in totality for as long as we can.
Making that happen takes extreme precision. Scientists calculate exactly where the airplane needs to be at each moment.
We do a lot of missions where being in the right point in time and space are critical, and this is one of them.
On Eclipse Day, the WB-57 aircraft climbs more than 50,000 feet into the stratosphere. That's above most of Earth's atmosphere, where clouds, dust, and water vapor could obscure the view.
Viewing an eclipse from 50,000 feet provides a really clear shot of the sun. And that allows the scientists to have confidence that the data that they're seeing is from the sun rather than distortions from the atmosphere.
When the moon's shadow arrives, it engulfs the aircraft.
It's weird. Right where you're at, it's dark, but everywhere you see it's twilight. And the temperature in the cockpit drops, so it's very noticeable.
As the eclipse unfolds, the pilot keeps the aircraft on course, while the sensor operator fine-tunes the cameras, capturing every second of data.
You're very, very, very busy, and it's very high pressure because, of course, there's no do-overs. You only get one opportunity to get all these instruments trained on the right spot.
For the aircraft crew, it's a chance to witness one of nature's most spectacular events while helping scientists better understand our sun.
I'm sitting in the best seat in the house. It's pretty exciting.
Wow, what a job they have today. For this eclipse, the WB-57 aircraft has a camera on the nose of the plane that will be capturing images of the sun's corona. To learn more, let's chat with Principal Investigator Amir Caspi, who is chatting with us live from Keflavik Airport in Iceland. Hi, Amir. Thank you so much for joining us today.
Hi, Joy. It's a pleasure.
So firstly, how are you feeling right now? And can you tell us what experiment you're doing today?
Yes, well, feelings are mixed today because, as you can see behind me, the sky is not very great for those of us here on the ground. On the other hand, we have an airplane that's now cruising at 50,000 feet above sea level that's preparing to observe the eclipse in just about 14 minutes. And we're going to be imaging the solar corona with an instrument that has 4 cameras on board with observations ranging from visible light through near infrared all the way to the mid-wave infrared, which we often refer to as the thermal infrared, to make new observations of the corona and learn all about coronal structure and dynamics.
What is it about the corona, the sun's outer atmosphere, that we're still trying to better understand?
Well, you know, we've known for about 100 years now that the corona is incredibly hot. It is millions of degrees hot, even though the solar surface is only a few thousand degrees. And we're still trying to understand exactly how the corona's magnetic field carries that energy up from the solar surface into the corona to heat it to those high levels. Our observations today will open new discovery space with wavelengths that are very rarely observed, that will allow us to apply physics models to better understand how that corona is heated. We'll also be looking at the structures of prominences or material from lower down that's kind of suspended in the corona that we're still trying to understand, especially in these infrared wavelengths where we don't have a lot of observations. And all of this will also help us to understand, of course, the sources of space weather that affect us here on Earth.
And so I know you flew this experiment and a similar one during the 2024 and 2017 total solar eclipses. What did you learn from those eclipses? And are you making any changes to your experiment for this eclipse?
In 2017, our first attempt at this kind of observation, we didn't even know what we were going to see. And measuring in the midwave infrared revealed new observations and new measurements that I think opened up the possibilities of lots of future experiments to try to better understand this emission from the sun. In 2024, we flew an upgraded instrument, the same one that's flying this year. It has 4 cameras measuring across 9 different wavelength bands. And we learned quite a lot, although we're still analyzing that data. So I don't have any results to share with you right now, except to say that we saw some amazing structures, and it'll be very interesting once we complete our analysis.
Yeah, I'm looking forward.
For this year, we're flying the same... Oh, sorry, go ahead.
No, go ahead.
For this year, we're flying the same instrument, and we're not making any changes to it from 2024, except that we're applying all of the lessons that we learned from the prior flights, including being able to fine-tune the observing time and the observing procedures. And of course, we also now have our data analysis pipeline that's already made from 2024, which will allow us to combine this data with the data from 2 years ago to make new scientific measurements much faster than we were able to do in the past.
Thank you so much, Amir. I know the plane is about to be capturing the eclipse in about 13 to 14 minutes. So best of luck out there. And thank you so much for joining us.
It's my pleasure. Thanks so much.
So Let's take a look at the telescope views right now. The partial solar eclipse has just begun in Spain. You can see a little slither of the sun that's been cut off on the one of the sides. The moon has just started to move in front, and it'll take roughly an hour or so before it completely covers the bright disk of the sun. Thank you again to our partners for these beautiful telescope views of the solar eclipse. We're about 10 minutes away from totality in Reykjavik, Iceland. The telescope views there are cloudy at the moment, but what we're seeing in front of us are views from Spain, and hopefully the skies stay clear for Spain. And fingers crossed, that is what we want for a total solar eclipse, is clear skies. So before totality comes, we have a few minutes to show you different types of science NASA has been conducting in Iceland for years. Iceland is a great place for astronaut training due to its terrain. A few years ago, the Artemis II crew and the science team spent some time there to prepare for the Artemis II mission. Let's learn more.
Iceland is a really wonderful place. It's a great place of interest for geologists, but it's also a wonderful analog. On Artemis, we'll visit the lunar South Pole, we'll make observations from orbit, and we have a whole new set of science questions that we hope that Artemis astronauts will help us answer for the Moon and Mars, which are, of course, planetary bodies we're really excited about for human spaceflight. Specifically for the Moon, we have features here in Iceland that are geologically relevant to the Moon, and also just have a sense of scale and a sense of identity that really mimic what we know the lunar surface looks like. There's a reason Apollo astronauts trained here, and there's a reason we're bringing Artemis crew here now. This is just a really wonderful place to learn about processes that shape the Moon and to really understand what it feels like and what it takes to actually navigate and do an EVA or a spacewalk on the lunar surface.
In Iceland, we are doing field work. We're training crew members. This is a key location for training for Artemis crews. Here we see in real time volcanic features that were created not long ago. It's a real special place for doing training for geology. I'm here in Iceland training the Artemis II crew in geology. There's really transformational science that we can learn by getting boots back on the moon, getting samples back, and being able to do field geology with trained astronauts on the surface, making observations that only they can make from that perspective.
Everybody start to see maybe softball size,
It's a fantastic place here in Iceland to be able to train geology. Also, navigation skills are another big component of what we're doing out here in a beautiful environment like this, out here camping in the highlands of Iceland.
Wow, what an office to work in. So later on in our coverage, we're going to be taking a closer look at the student ballooning experiments as well. And that's been taking place in Iceland for the past 24 hours. But now we're going to be chatting with Marie Henderson, who is the Artemis II Lunar Science Deputy Lead. She has experience training in Iceland and has a key role in the Artemis II lunar flyby data collection. Marie, thank you so much for joining us.
Thank you so much for having me today.
So during the Artemis II mission, the astronauts were lucky enough to see a total solar eclipse from space. Not to be corny, but that's what I call sun and moon joy. Was that something that was planned from your side?
We knew that it was a possibility that we could have a solar eclipse during our lunar flyby. So months before, we prepared our lunar imaging procedures, some of that based on what we learned during the Apollo program, but also some that we learned from imaging that took place during the 2024 solar eclipse. And so we used that to prepare our cameras, but also once we realized we were coming up on a launch day, especially in April, where there was that possibility, we had to go back and we had extra time to train the crew on what they were going to be seeing during this eclipse and what types of observations the scientists were really excited to learn from them for.
Wow, what a lucky alignment of stars.
Yes.
Is seeing an eclipse from space any different from Earth? Did they see different things, and did they have to wear eclipse glasses?
Yes, the crew did have to wear Eclipse glasses, and so we got those manifested, as you can see on your screen, for them to make safe observations. One of the large differences between what the crew saw as they went around the moon and from here on Earth is we look at an eclipse through Earth's atmosphere, and so they didn't have to look through an atmosphere as they're going around the moon, so they're able to see the full extent of that corona as well as the zodiacal light in the solar system.
And how long was the eclipse up there?
It's about 53 minutes long, so they got a much longer chance to look at that eclipse.
Wow, what an opportunity. What was the day like for you in the SUR?
It was a very exciting day. This was not something that we really knew exactly how it would be, and so we had just had a beautiful lunar flyby of the illuminated portions of the moon, and then we turned to watch this eclipse. And the descriptions that we heard coming down saying that they were, this is sci-fi, and they couldn't even imagine, and this glow, we didn't see that in our coverage, but once those images started coming down that night, it was mind-blowing to see exactly what they're describing, and I wish I was there myself.
Same. Well, that's incredible. So Artemis 2 has just launched, and so we have Artemis 3 to look forward to. Can you tell me how you're preparing for that mission?
Yeah, so Artemis 3 is a different type of mission. We're not going to be going to the moon. We're actually going to be working in Earth orbit. And so this will give us an opportunity to test our human landing systems, which will be the spacecraft that we take down to the surface of the moon. And so we'll work to hopefully dock with one or both of the human landing systems. But we're also going to have an opportunity to do a lot of science at Earth, because this will be a new, unique viewing orientation as well.
Wow, what an exciting few milestones to look forward to. Well, Marie, thank you so much for joining us today.
Thank you so much for having me.
So if you've just joined us, take a look at these maps that we're showing you right now that's showing the path of the moon's shadow. You can see that it's close to reaching Iceland. We're about 5 minutes away from totality in Reykjavik. And over in Spain, you can see that we have about 45 minutes left until totality reaches them. So these are views from Villabado in Spain that we're seeing right now. And if we switch back to the map, you'll see that the moon's shadow actually looks pretty slow as it's traveling across down towards Spain, but it's actually traveling at over 2,000 miles per hour. These maps were made by my colleague Ernie Wright. He used various NASA satellite data to create super accurate maps for us. If you want to view and download them yourselves, you can visit science.nasa.gov/eclipses. So now let's welcome back NASA heliophysicist Dr. Kelly Corrick. Kelly, how are you feeling about today's eclipse?
I'm excited for everyone, and I know those clouds are a little worrying in Iceland. That's one of the reasons we had the plane, but also joyful to see the balloons that are going to be launched, as well as seeing it in Spain. So really excited.
Yes, and I'm sure the NASA pilots must be excited as well in the plane.
Yes, exactly. It's a great view. It really is a great view from that.
So here we're seeing a live view from the WB-57 aircraft sensor right now. They're moments away from seeing the moon's shadow hit Earth and also chasing the eclipse. And we haven't actually seen the view of the corona yet from the nose, but they will be capturing images once totality hits Iceland. And on the right-hand side, we're seeing a partial eclipse from Norway, which is really exciting. So we have places across Europe that will be able to witness a partial solar eclipse. There'll be many, many people here that will be able to experience this amazing celestial event. So let's see how many. We're about 6 minutes away from totality in Iceland.
Yeah.
What do we expect to see right before totality?
Right. So right before totality, we're in that partial eclipse that's going deeper and deeper, and you start to see things go dark. So even if there are clouds, it's going to get a little bit darker. The weather is going to drop too, because again, you've blocked out some of the sunlight, so you're going to get cooler. There's some wind that'll pick up. So the eclipses are really full body experiences. You might also notice that animals react as well. It's not just humans that experience this, but if there are any animals, they might start to pretend that it's nighttime or realize it's nighttime and start to kind of nest. And this is very unique for that part of the world, because right now they're on almost 24 hours of sun. So they are going to be a little shocked by this. And so you'll be experiencing a lot of different things, even if you don't get to see the beautiful corona.
Yeah, I'm thinking about everyone on the ground in Iceland right now. They may be seeing clouds, but can you tell me, how does the climate shift when an eclipse happens? Because I've heard that the weather can change drastically.
Definitely. So from personal experience, in 2017, I was in South Carolina and there were thunderstorms. And during totality, it parted just around the sun and was able to actually fully enjoy the eclipse and see my first total. That was my first total solar eclipse. So there is hope that the clouds are influenced by that change in day-night, that eclipse that's coming through. So we're hoping that some of the winds and some of that changes could change things for Iceland.
Okay. So we're seeing right now on screen a live telescope view from Spain, and that's because the telescope views in Iceland are obscured by clouds. But as Kelly mentioned, I'm hoping that the clouds will part and the weather will change for them. Anything can happen at this point, right?
Right, anything can happen. And also, we'll talk about it a little later, but the balloon experiments, they are testing the atmosphere. The atmosphere of the Earth is still being affected, even if there is cloud cover, and that helps us with predicting weather models. So it's not just about the coronal science, which is something that I'm very passionate about, but it is also about understanding our planet and how it interacts with the sun and the light that we're getting from it. And you see, we're starting to see something in the WB57. It's getting very close. They were zooming in there, so that's
okay. Wow. Okay, so everyone who's watching right now, the right-hand box, you will see the live views from the WB57 aircraft. That's where the NASA pilots are chasing the eclipse from the skies. So Kelly, can you tell me what are the benefits of observing the eclipse from up there?
From observing up there at 50,000 feet, wow, okay, so I'm looking at these are great. 50,000 feet, you're able to get above all the clouds. So they're above all the clouds, and we're able to, again, allow it to overtake us, so they get a few more seconds of totality. You saw that beautiful pink filament on the sun. That is something that Amir talked about, is that filament, that material that comes off the sun that can actually create space weather and affect our power grids here on Earth. It can affect our GPS. So if you ever use your maps to get anywhere, that's something that we need to understand to be able to predict. It also affects our astronauts, our dear astronauts, so making sure that they're okay. So those things are really important to study, and one of the reasons why we have the WB57. It's a little hard to see, but in the words on the right-hand side, you see that pink filament now on the WB57 feed, which is on the right-hand side. And so you can see it in the NVIS area, now kind of right in the center. You're seeing that prominence. And so this is amazing data. And it might not look as crisp as we're used to. You know, we're used to 4K down here. But this is really data a scientist can love, because this is telling us very specifically about part of the data. So it's like taking only a little part of the TV stream in and really getting the information about the iron or the oxygen or the specific composition of what that's made of. And if we know what it's made of, we can do more science with it.
So we're about like a minute and a half away from totality in Iceland. And so we have a minute and a half for the clouds to part. So the sun view that you're seeing here, that is not of Iceland, but that is of the partial eclipse in Spain. Iceland is still being covered with clouds, but totality will hit them in about just a minute or so. And luckily, our airplane, the WB57 aircraft, they're going to be getting clear views of the eclipse from the skies. So we're going to be seeing what the camera on the nose of the plane will be seeing in roughly 1 minute, which is so exciting for them.
So exciting, yes, definitely. And you are starting to see some of the what would be a diamond ring effect. So those little pink things that you're seeing, this is happens when light passes through the valleys of the moon. So you don't have a perfect circle in the moon. It has those craters, and there's that diamond ring effect.
Oh,
so
wow.
so just absolutely beautiful. And that's when you still should have your glasses on. And when that ends, that's when we're able to do it. And I want to comment, this is an experiment, right? And so this is part of the reason why we're seeing kind of the arrows or the crosshairs go in and out. We are real time. This is real time live. How science happens is that we are trying to make sure to make adjustments and make sure we're getting an image.
Wow.
Yeah.
So we are 7 seconds down to totality in Iceland. This is really exciting. We're getting a shot of the ballooning experiment as well. This is the nationwide Eclipse ballooning project. They've been launching balloons for the past 24 hours leading up to this eclipse, which is so exciting. And I can see that they're getting really excited as well, despite the clouds, because they can actually still collect data even though they can't see the eclipse. Is that right?
Exactly. They can still collect data. They are still experiencing a little bit of that darkness. It's obviously darker. See, it's definitely darker, even though you can't see the corona itself. And a little bit looks like sunset around the 360 degrees. And hopefully we'll see this in Spain, where it'll be very vivid imagery there.
So it looks like totality has hit Iceland, which is so exciting. You can see that the ballooning team is engulfed by darkness here. So that is so exciting. I can see them smiling. Oh my goodness. So why do we see a 360-degree sunset during an eclipse?
Because there is light on either side. It's just simply blocking out in that specific shadow. So it's like the sun has gone down just in that one location, but the rest of the earth is still illuminated. So you still have oh wow, that is images of the sky and the airplane. We are seeing the airplane.
Wow, so we have experiments happening in the air and on the ground in Iceland, which is so exciting.
Definitely.
Wow. So, and then what we're seeing now is the partial eclipse happening in Norway. They will just be experiencing a partial, but in Iceland, they are experiencing totality right now. We have experiments, balloons capturing data in the skies, and also a plane capturing data in the skies as well.
Yes, we do. And it's really interesting looking at the sun. There are some features, those lines that you see, the dark lines, those are magnetic features, and those again are the exciting things we want to know about for space weather, and so to better understand that. So the sun has given us some very interesting things to look at, and those experiments will really, really help us.
Yeah, and so this is why eclipse observations and eclipse chasing is so critical, because even though they happen often, and even though we know exactly when they're going to happen, you never know when the weather will just obscure your view. So we want to take every opportunity we can to get observations.
Definitely.
So, okay, so if you were in Iceland and you were either seeing clouds or you were able to see the eclipse, please share your experience with us. We want to know what you experienced on the ground. Please tag @NASA wherever you're watching. So we have a lot of questions coming in here from social media. So Kelly, shall we dig into those questions?
Yes, let's dig in.
Alrighty, so we have Bo on Facebook, and they ask, are we really going to lose gravity during the eclipse?
No. We are not.
Okay.
Gravity, really, the stuff that sticks us to the Earth's mass has not changed because of this eclipse, and so we're going to stay grounded on this Earth.
Okay, noted. Gravity will not change. Okay, so we have another question from X, and they ask, how much can we actually learn about the sun during just a few minutes of totality compared to years of normal observations?
It's really about having all of the observations, right? We definitely need that totality because the moon just happens to fit so perfectly over the surface of the sun that we can see from that surface outward for that space weather, whereas some of our instruments aren't quite that close in. So we need to knit them together and use both the couple of minutes from the eclipse as well as the years of observations from our NASA satellites.
Okay. Well, I'm glad that we have both ways of getting observations.
Exactly.
So we have another question here from Elinu on YouTube, and they ask, why does the weather change in a solar eclipse?
That's a good question, and I think that's something still trying to be understood. But if you imagine you've stopped heating something up temporarily, so things sink, right? When things get cold, they tend to sink, and so the air is moving, and there starts to create winds. And when you create winds, you start to cool things down. So the weather changes due to just turning on and off the light alone, because the sun is so important to us in actually regulating our weather.
Wow. Okay, so we have another question here from Frank Perez on X, and they ask, for sending teams to do research in the path of totality, how do you balance the crew training value of Iceland's terrain against the statistical odds of clearer skies in Spain?
And we definitely addressed both, right? There are great things to do with the atmospheric work, especially in the Arctic areas, for the balloons that we sent to Iceland, and then we have teams in Spain also doing that. So it was a balanced portfolio. We made sure that we had both types of experiments available.
Okay. Thank you so much. So keep your questions.
All right, so welcome back everyone to the live coverage here of the solar eclipse, and I'm now gonna just go with my commentary from now on, because I'm just gonna say frick this feed that I'm on now. Since next up is basically the I was gonna say there's something weird going on. All right, so in 37 minutes, I probably got. Oh, that's just very unfortunate. Mosquito bite. Don't tell me, man. I'll actually get pissed. Anyway, we're currently getting some more views of the solar eclipse. View from ESA. Probably gonna have to put them in the description as well, I guess, if I haven't already. We're having ESA live feed from the same place in Spain, the same mountain, the same top. And we're looking at that right now. Just want to get the main feed back on. So I apologize for the loud sounds here. I might, let's see, do this. Alrighty. So we got more views of the solar eclipse now, so we have uncut footage of this, which is never going to go to an audience, remember? Which is going to be useful for once it does go to totality and then switching to another feed. So people just joining us, friends of friends maybe, because I heard someone invited someone. I don't know if you're still watching, but if you are, hello. Yeah, we're currently a little under 36 minutes until totality here in Spain, Tyrol, Spain. So it's going to be very cool. Of course, the full 90% here in the Netherlands will be before that, about 20 minutes before totality here. So actually, that's going to happen. Ooh, it's already quite dim here, I should say. And I mean quite, but it's like, it's really. So about in 15 or so minutes should be totality, or not totality, 90% here in the Netherlands, which is 8:11 p.m. local time. Excuse me there. We're back here now. From now on, this stream will have my commentary, or one of my friends. I don't know who wants to do commentary. Did it cut away again? It's funny to see that People have no idea that I'm live right now. Like friends, I have no idea I'm live right now. And I still don't know why on connected apps on Discord it doesn't show my YouTube that I'm live. It's like, what? Oh wow. It's a little dim here in the Netherlands, so it's visible now. Ja, maar dat komt ook omdat de zon gaat, of niet? Oh wow. Time to share someone my live stream. Grote nieuwe live. Anyway, continuing on. You can see now it's still 30 minutes off. At least in Spain, I should say. So at the moment, it's just chill. Currently 30 minutes out until totality in Tyrol, Spain. And 9 minutes until the maximum eclipse point in the Netherlands, at least for me. What I can personally notice here, it's a lot more dim. It's not as bright as it should be around this time point, whatever. Which is kind of cool. Even with this 90%, it's still quite visible in the overall sky. I'll make a comparison from today at the timestamp and tomorrow exactly 24 hours later if it's not cloudy or anything, which it isn't, so that's good. So I'll make a comparison at exactly 8:11. And then 24 hours later tomorrow at 8:11 and see how much is gone dimmer, to say the least. But it already seems odd to me, which means the solar eclipse is happening. And it's already... I mean, it's close. It's much further than it is. Let's see if there are any people out in the Netherlands. So Iceland has just got the solar eclipse, which is nice. Well, there we go. People in the Netherlands. Oh, there you go. We have people out. There you go. Just seeing it from my phone. Absolutely awesome. Now the sun is already low. It's very nice to see all the shots from all over the world. Well, all over the world. What am I saying? Help me. I meant, of course, seeing those shots from Spain and the Netherlands. Currently about to make some photos of my own here. The commentary will be reduced again. Yo, you can see it. Wow. Okay. Yeah, it's concerningly dim is what I'm witnessing. It's concerningly dim. Which is kind of scary, because I've never seen a solar eclipse to this extent before, where it's 90%. Yeah, no, I've never seen 90% before in my life. I do wish also to experience 100% whenever I get to experience that in my lifetime. Probably not here in the Netherlands, of course, because next solar eclipse in the Netherlands is... just guess. It's... like, the next 90% is 2081, but after that, like, 2142 or something. Like, it's absolutely ridiculous. Okay, so what I'm gonna do now, in the next few minutes there will be maximum totality here in the Netherlands, and I will be going outside now to witness the beautiful skies in the Netherlands, and I'll make sure to record and stuff like that. So until then, enjoy the sounds, and we'll be back shortly. All right, chat. I'll be right back now. Papa. Maar dat is dus het gevaar. En dat zie je niet. Ja. All right, welcome back. A very exciting 10 minutes, I should say. To describe once again, it is pretty much what I thought. It's so dim. It's dimmer than you would. It's just dimmer. It's like it's an odd 8 p.m. But that's the cool part. Anyway, I did make some pictures. I will share them with y'all as soon as possible. It's pretty cool, to be honest. Probably share them in my socials. I'll tell you it's cool. That's the hint I'll give. It's dark, but you see some. It's cool. But it's not over. The game's not over. The game's not over. We still got. Oh. Stand by here. But yeah, now that's over. We still got another one to look forward to in 10 minutes and 50 seconds. The one that most of you probably have came for to witness. And that is the solar eclipse over here. In Teruel, Spain. I still cannot pronounce it right. A little stupid for even doing it. Anyway. Once again, I will release the photos. Not pretty much pretty photos, but it is some kind of picture of some kind of solar eclipse. Those photos will be shared later. Well, that is a very cool shot. Oh, it's just bright, but it's through the clouds. You can see it perfectly on this camera without any filter. Now, I'm scared for the camera's lens, but I believe it's fine. I mean, it's through thick clouds, so I hope it's fine. But we'll find out soon enough. But there it is. Beautiful shots there. As we're 9 minutes away. And it's very close, too, so... Totality is going to be cool. Once again, we have those shots for you. I heard they have drone shots out of the area, so you can see how dark it actually gets once it happens. It's really cool. I've seen videos of it before. Personally, haven't seen 100% solar eclipse before. But yeah, I'm going to see it in recording action again here. So, hopefully, if cool shots of how dark it gets. So, yeah. There you can see once again how far that sun is now blocked. Looking good indeed. Look how beautiful that is, isn't it? So that's where we are at now. So we have two views of Tyrol, Spain. Basically three, technically, but... Boom, dark. Just saw from one of the cameras there. I am working behind the scenes with everything that's going on right now. So I'm in control, switching views now, which is kind of crazy. Boom. Once again, we are 6 minutes off from totality here. And I believe it's probably earlier one of the zones. I think this is around the coast of Spain here. This is around the coast of Spain, so it might be earlier, but from the location in Tyrol, Spain, it should be about 5 minutes out. But indeed, it's going to be earlier here in another zone. I believe... is that actually the mountaintop? So the beach is gonna get... Huh? That doesn't make sense. So the beach is gonna get it later. The beach is gonna get it later than... I don't buy it. Anyway. I mean, we'll find out soon enough. This might be beach, though. This might be beach. I'm not sure. If this is beach, that's cool. I guess. I have no comment if this is indeed beach. Sounds like saying the B word every time. I mean, it's almost totality here. Which one is that? It's almost totality here. Hold on, let's get the countdown over. Here we go. Let's listen in. And there's totality. And there's that corona you see of the sun. It's very cool to see. Look at that. Now this eclipse is in total 1 minute and 54 seconds, I believe. Look at that. That is the beach side, so I was right. Let's listen in because it's happening as well here. Okay, so it's happening now in Tyrol, Spain as well. I mean, we should be close now, I guess. So it's happening earlier than my timing said. So let's just see. Oh, and there it comes out the other side on the beach side here. So let's see it now happen in Tyrol, Spain. Could be wrong. I think it is this one. Yeah, there we go. All right. Look how dark it's getting there. There we go. So this is the right location. Now it's happening. So apologies for the confusion there. 40 seconds until totality. I got it correct this now. So I believe the other feed was delayed indeed. But there we go. Now we got the real deal. So this is going to be cool. Oh, there we go. And there's totality here. This time for real.
Esto no lo volvemos a ver, ¿eh? Es muy fuerte. Pero mira cómo se ve. Así. Ana, mira, mira que hay un puntito rojo.
That's awesome sauce.
Puntito rojo.
So this is going to be the last, I believe, 50 more seconds. 5-0. Here comes the diamond ring. Wow. All right. And that is the Solar Eclipse 2026. Once again, awesome sauce.
Mira, vamos a poder ver aquí la fase de retirada, que en otros puntos de Aragón no se van a ver, porque está tan bajo, estamos tan altos que lo vamos a poder ver, pero en otros sitios no van a poder ver toda la retirada.
That was a very cool shot from ESA capturing the solar eclipse. You really saw the corona there. Might have to look back at it, but that was insanely cool. Just 20 minutes later than in the I can see it looks much brighter now in the Netherlands. It's less dim. So that's cool. That's cool. Oh wow, good shot. The drones really did their work this time. That is absolutely magnificent. Like it actually, that was actually awesome. It did its work at this time. That was just, by definition, cool. I mean, I guess that's it. That is the 2026 solar eclipse from no, we didn't really see from North America and a little bit of Iceland. So let's just say we saw it from, at least I saw it from the Netherlands and Spain. I believe Iceland was captured on there. Oh, look at that. That's cool.
Alba, ¿quién la ha contado tú, no? La has contado muy bien, ¿eh? La has contado genial.
Ha sido espectacular.
Qué pasada.
Ha sido genial, ¿eh? Es una pasada.
Sí, sí. Pues nada,
Qué emoción, qué emoción. O sea, al principio pensaba...
The sun coming through. That was absolutely amazing there.
Wow, fantastic, fantastic. I mean, the experience once in a lifetime. You can guess what it's going to be like, but at the end you have to live it. And with Brian May.
And there you can see the sun just pass through. But indeed, very incredible to see that solar eclipse, even if it's just me sitting here watching a screen. It's still magnificent, and I cannot imagine how it will feel in real life whenever I get to experience that. I'm sure I will sometime. I mean, big tip, y'all should watch it as well sometime if you have the chance to, if you haven't already. It's so magnificent. Like, I can already tell from the views I'm seeing here. Like, even as the sun is about to set in about what it is, 1 hour, 30 minutes. Still odd to see. And for sure in this condition, like pre-sunset and then the solar eclipse. That's sick. And a chance to see the corona of the sun as well, so. Alright, well, I think that will conclude our coverage here on 2 streams. My stream and Bravo Yankee Tango's stream. The TSDG clean feed will still be running for probably 20 more minutes until we cut that off to here. Just not to make anyone confused, it has already ended. But yeah, we'll run the clean feed stream for just 20 more minutes. If you want to stick around there, you can. And until then, I guess we will be ending our coverage here today. Next time we will be back will be a very, very cool one. I would say a very cool one. It is the Falcon 9 launching the USSF 366 mission, or 366. I would rather say, I just didn't know how to say it. But we will be back there. That's in a few days from now on the 15th of August. So that will be it for me. Thank you guys so much for watching. And until then, we'll see you next time.
Allumage 2 ESR, décollage.
And liftoff of New Glenn 3.